Okay, this is the P4 paper from January 2021. It's question number 4. Clearly we can see this is a vectors question. Let's have a look at it. It says we've got vector AB in that direction there and vector BC in this direction here. The direction is going to be important in a minute. And it says for part A, can we find the size of the angle ABC? So if I want to find the size of that angle there, we'll worry about part B in a second. If I want to do ABC there, I can clearly see that that's going to be an obtuse answer, obtuse angle. We're going to use the idea that if we have two vectors A and B here, A and B, and that angle there is theta, then hopefully everybody doing this knows that A dot B is equal to modulus A modulus B cos theta. So if we've got A and B, we can work out A dot B, we can work out modulus A, we can work out that. So we'd be able to work out what cos theta is, so we'd be able to work out the answer. But if you look at my diagram here, what I've actually got is that both of these vectors are coming out from the points, and we don't have that situation up there. We've got the ABs going in that direction. So what I'm going to do is I'm actually going to change that vector round, and I'm going to do BA. If I then do BA and BC as my two vectors, everything will work out fine, and I'll be able to work out my acute answer. If you didn't spot that, all that will happen is when you do your A dot B is equal to modulus A modulus B cos theta, your A dot B is going to work out to be a positive value. You'll get plus 26 there. And so what you'd actually get is you'd get an acute answer, and you'd be getting that angle there. If you want to do that, there's no problem with it, as long as at that stage, say that you get that as being 70 degrees, you then look at the question and say, oh, hang on, no, that's not the angle that they wanted. It's 180, take away 70 degrees. Right, hopefully I'll make that a bit clearer when I actually go ahead and do it my way. So in my way, what I'm going to do, let's just tidy all this up. With my way, what I'm going to do then is I'm going to start off by saying, for part A, the first thing I'm going to say is, if they've given me AB, I'm going to say BA. So BA is minus 6i plus 2j minus 3k. Nothing complicated, I've just flipped it all around like that. And then I'm going to tell them what I'm using. A dot B is equal to modulus A modulus B cos theta, or cos theta is equal to A dot B divided by modulus A modulus B. Right, what's A dot B then? Well, A dot B is equal to, I'm just going to put this as a column because I think it's easier to just write it out and do the calculation here. Whichever you prefer to use, you can do. You can mix and match them. So that's going to give me minus 12 plus 10 minus 24. So I'm going to end up there with minus 26. If you hadn't done my bit here, you'd end up with 26 there, and then the inverse cos you'd get would be an acute angle, whereas I'm going to get an obtuse one. Modulus A is just the square root of, and then that's minus 6 squared plus 2 squared plus minus 3 squared. That works out to be root 49, or rather 7. Modulus of B, that just works out to be the square root of, and then the other one, 2 squared plus 5 squared plus 8 squared. And apparently that's root 93. Okay, so subbing everything in then, I've got that A dot B minus 26 is equal to 7 root 93 cos theta. So I'm going to get cos theta equals minus 26 over 7 root 93. So I'm going to end up with, inverse cosing that, I'm going to end up with an obtuse angle, 112.65 degrees. They did want it to 2 decimal places. And as I say, if you hadn't have done that first step, then you'd have got a positive there, you'd have got a positive there, which means you'd have got 60 whatever, and you'd have had to say, no, that's not my answer. My answer is 180, take away that. Wouldn't have been a problem. As long as you get the final answer, I don't think the examiners will have any issues with that. Okay, on to part B. Part B says, can we find the area of the parallelogram ABCD, giving your answer to 1 decimal place? This is a fairly well-trodden route for doing this. What we're actually going to do is say, if I draw that line in there and work out the area of the triangle ABC, I can then just double that, and that will give me the answer for the parallelogram. Okay, so let's just make that clear to the examiner. Part B here. And I'm going to tell that I'm doing area, if I can write, area of triangle ABC, and that's just our half BC sine A. No problem with doing that. So that's going to work out to be half. We've already got BC because we've got the moduluses from before. 7 root 93 sine the angle that we had. Keep the exact angle on your calculator, please. So that works out to be 31.15 units squared. So the area of the parallelogram is going to be 2 lots of that, which should give me 62.3. What were the units? Does it say anything about units? No, so I'll just say unit squared. Okay, hopefully that's relatively straightforward, including that little bit of teaching right at the start, and hope that all makes sense.